Moving to question number 4. It's a straightforward, short and sweet question that has been derived from screw gauge. And the question says something like this. The least count of the main scale of a screw gauge is 1 millimeter. Alright, the main scale division. The minimum number of divisions on the circular scale required to measure 5 micrometer diameter of the wire. So let's try to see. The 5 micrometer diameter, if you want to measure, and it says the minimum value, therefore 5 micrometer should be the least count in the minimum condition. So I get 5 into 10 raised to the power minus 6, that's the least count, and least count equals to pitch, which will be 10 raised to the power minus 3 divided by the number of circular scale division. So that's a basic definition. And here we are supposed to calculate the value of n. It is very straightforward. On solving, n will be equals to 200. So for question number 4, first option comes out to be the correct one. Fine then, now it's time we move to the 5th question. Fine, now let's see question number 5. And this has been set from the topic of progressive wave, a very straightforward and an orally solvable question. Let's see what it is. It is something like this. There is a traveling wave which has been given, and the equation is this much: 10 raised to the power minus 3 sine 50t plus 2x. And based on this information, if you see the 4 option, it is essentially asking that in which direction is the wave traveling and what is the wave speed. Well, it's so clear that since this and this, the coefficient of x and t have the same sign, so the wave is certainly traveling in negative x direction. So if the wave is traveling in negative x direction, this option and this option would be eliminated. And what about the speed? Well, the wave speed is omega by k, and omega being coefficient of t, that's 50 by 2. So the wave speed would be 25 meter per second basis the unit out here. So first option would be the correct option for question number 5. Time, we move to question number 6. Let's see, what does question number 6 has to say? And it says that there is a rod of length L extending from x equals to a to x equals to L plus a. So the rod of length L from a to L plus a, the gravitational force the rod exerts on a point mass at x equals to 0. So it's clearly the case of force interaction, and mass per unit length of the rod is given as a plus bx square. That means the rod is variable. That is what we have to say, variably mass distributed, more precisely. So let me draw the situation. That would be a better way. So here is the rod. So this is the given rod, and we need to be very, very careful that here is the origin, and this is x equals to a, and this is x equals to L plus a. So L being the length of the rod. And we've already known that the linear mass density that's given as, let me just check, perhaps that's a plus bx square. Yes. So the linear mass density is a plus bx square. Now, another important thing is that here is that point mass m. So the idea is very, very clear, no big surprise, that we will divide the entire rod into number of point masses and we'll find the interaction between them. Okay, so here's the situation. From this point at a distance x, you consider an elementary mass, and how much is the force of interaction between this point mass and this? So that's g m a plus bx square dx. All right, so this is that small mass, and that will be lambda multiplied by this small length, g m1 m2 divided by r square, which is x square, and the integration limit will be from a to a plus L. That is going to give me the total force. And rest is a very simple integration, no big deal on that. I'm pretty confident you'll do that. You do this and your answer is going to match with option number 3. So therefore, third option is going to be the correct option for question number 6. Fine. Now let's move to the 7th question.